So now we want to find the inverse of a graph, or the inverse of a function from the graph. Okay, so example 6. Graph on the same coordinate system the inverse of the one-to-one function. So they already tell us it's one-to-one. You could check that by looking at it and saying it passes the vertical line test, it passes the horizontal line test. And then we're going to graph right on that same grid, we're going to graph the inverse. Okay, so one way you could do this is you could think about what is the original function. Well, the original function has ordered pairs -3, -4. You could do this with a table of values as well. -2, -2. So I'm looking at each of these individual ordered pairs here that they tell me. 0, -1, 1, 2, and 4, 3. Okay, so the picture, the graph they give us, it passes the vertical line test. It also passes the horizontal line test. It is a one-to-one function. They tell us 5 ordered pairs. Now, how many ordered pairs are there actually on this graph or that function? There's an infinite number of ordered pairs. Those red lines represent an infinite number of ordered pairs, okay? So you can't list them all, but we just are listing the ones they gave us. Now we're going to graph the inverse. So over here, what I'm going to do is I'm going to write a list of points that I know are the inverse points. Well, switch the x and y. So -4, -3, -2, -2, that one stays the same. -1, 0, and 2, 1, and 3, 4. Okay, now I'm going to graph these ordered pairs. So where is -4, -3? -4, -3. It's right there. Where is -2, -2? Well, it is right there, still at -2, -2. -1, 0 would be right here. 2, 1 would be up here. And then 3, 4 would be up here. Okay, then I connect the dots. So there's this section, this section, this section. It would help if I had a ruler. And this section. Okay? So in the inverse, there's an infinite number of ordered pairs. And we can't list them then, but we can show a picture. And there's this graph here. Okay? I'll try to draw it a little bit thicker like their line. Now, one thing that's true about a function and its inverse, if you graph them, so look at this diagonal line. Oops. Diagonal line that goes through the origin and has a slope of 1. That is the y equals x line. If you look at that diagonal, and you were to fold your paper, your graph paper, on that diagonal, all the points on the function would match up on top of the points of the inverse, okay? So it's symmetric about that line. And symmetry is probably not a good word to use, but the function and the inverse are symmetric about that line. Okay. I don't know if the book points that out, but that is a quality of an inverse and its function. They have to do that.